This video is going to continue with solving radical equations part 2. So we are on question number 4 in our video notes. And let's go ahead and go through step 1. We want to isolate the radical, so that means we want the square root of 5r minus 1 to be by itself. So to get rid of the negative 7 or minus 7, we're going to go ahead and add 7 to both sides. And then, so that was step 1. Step 2 is we want to raise each side of the equation to the exponent equivalent to the index. So since there is no number here, we know that the index is a 2. So we're going to go ahead and square both sides. And remember from the previous video, when we square a radical, this radical is going to undo, leaving us just 5r minus 1, and then 3 squared is 9. So now to get the r by itself, we don't need a factor. There is no exponent in this problem higher than 1. And then we'll lastly divide by 5, and we get r equals 2. Now we have to remember the last step is check the solution. We have to make sure that when we plug this number in for r, that it won't produce a negative, since the index here is even. So we're going to go ahead and check the problem. So we're going to remove the r and plug in 2. Um, 10 minus 1 is 9. The square root of 9 is 3. 3 minus 7 is negative 4. So since we get the same thing on both sides, then we know that this is our solution. Okay, so let's go ahead and try number 5. So we want to get the radical by itself. There happens to be 2, but that's okay. So we have a radical by itself. So since the index is not there, we know it's a 2. So we're going to go ahead and square both sides. So on both sides, the radicals will undo. And so we're left with 5x minus 2 equals 3x. We do not need a factor. We don't need to make this equal 0 because there is no exponent higher than 1. So I want to get the x's on one side. So I'm going to go ahead and subtract 5x to put the x on the right. And then to get the x by itself, we will divide lastly. And we would get 1 for x. And again, we need to check it. It is not optional. We must check whenever the index is even. So we're going to go ahead and plug in a 1 for all the x's. We would have 5 times 1 is 5. 5 minus 2 is 3. So we'd get square root of 3 on the left side. And then 3 times 1 is 3. So because we get the same thing on both sides, we know this is our correct answer. Okay, let's go ahead and take a look at number 6 here. So step number 1, we want to get the radical by itself, which we can see that it already is isolated. So we get to skip step 1. Step 2 is we are going to raise each side by the index. So since there is no little number here, we know it's a 2. So we're going to go ahead and square both sides. So again, this will undo, leaving us just y minus 4 here. And then here we have y minus 10 times y minus 10. So we cannot distribute this exponent. We know that from previous chapters why we can't do that. So we're going to have to FOIL this. So we're going to have y times y, and then y times negative 10, and then negative 10 times y, and then a negative 10 times a negative 10, which is positive 100. So now we're going to combine the like terms here, negative 10y and another negative 10y. That makes negative 20y. And now we're solving an equation, and there is an exponent higher than 1, so that is how we know we need to set this equal to 0 and solve by factoring at this point in the class. So we're going to go ahead and subtract y to make that y 0 out there, and then we're going to add 4 to make that y, or I'm sorry, so that there's a 0 on this side. Okay, whatever we do to one side, we have to do to the other side. Okay, so now to factor this, there is no GCF. There are 3 terms, so when there's 3 terms, we use the AC method. So we have to think of what multiplies to 104, and it has to add to negative 21. So go ahead and think about that now. We know that it has to add to a negative, so we know the bigger number has to be negative since this is negative. But because it has to multiply to a positive, we know that a negative times a negative is a positive. So that's how we know both of them are negative, and these two numbers would work. So we're going to have y minus 8 and y minus 13. And then we set each factor equal to 0. And keep solving, and we would get y equals 8 and y equals 13. So before we box our answers, we have to check. Again, it is not optional. We have to check because this problem has an even index in it. So if we go back to the original problem, I'm going to go ahead and begin with checking the 8. So I'm going to go ahead and put 8 here and here. And we would have 8 minus 4 is 4. The square root of 4 is 2. And then 8 minus 10 is negative 2. So again, that means either we messed up and this is not right, and then if we check over our work and we feel good about this and it's not working, we know this is extraneous. So we're going to cross it out. Now we're going to try it again, and this time we're going to use 13 for y. I'm going to put 13 here. 13 minus 10 is 3. 13 minus 4 is 9. The square root of 9 is 3. And so that solution works. So if we were answering this, we should just write that our answer is 13. All right, let's go ahead and try one more here. So step 1, we want to get the radical by itself. So again, feel free to pause this video. Try it first on your own, of course. We want to get this radical alone, so we're going to subtract 1 to both sides. And then the next step is, if this index here is a 4, we're going to raise both sides to the power of 4. And what happens is these undo each other. And we would get 5x minus 7 equals 16. And there is no exponent higher than 1, so we don't need a factor like we did in the previous problem. We're just going to add 7. And then lastly, divide by 5. And we would get x equals 23 fifths. Or, if we put that in our calculator, since 5 doesn't go into 23 evenly, we would get 4.6. And even though I wouldn't leave it like it, you could also write it as 4 3/5. Those are all the same value, so I would do one of these.